Recursion. In this video, we are going to see about recursion in detail. Let's take a classic example, Fibonacci sequence, for recursive analysis. In mathematics, the Fibonacci sequence is a sequence in which each number is the sum of the two preceding ones. Starting from 0 and 1, the first few values in the sequence are 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. If we add 0 and 1, it gives 1. If we add 1 and 1, it gives 2. If we add 1 and 2, it gives 3. If we add 2 and 3, it gives 5. And so on. Let's see the pseudocode for Fibonacci series for better understanding. This is the base condition. When n value comes into the function as 1 or 2, then the function will return 1. This is the recursion call. Recursion means a function will be called by itself. Here fib function is called by itself. When the base condition fails, the recursion call will return. Now we shall look how this function works with the recursion tree. Let's assume n as 4. 4 is passed into function fib. Here base condition is not satisfied, so the recursive function is called fib of 4 minus 1 plus fib of 4 minus 2, which is fib of 3 plus fib of 2. Now 3 is passed into function fib. Again, here base condition is not satisfied, so the recursive function is called fib of 3 minus 1 plus fib of 3 minus 2, which is fib of 2 plus fib of 1. Now 2 is passed into function fib. Here base condition is satisfied, so it returns 1. Now 1 is passed into function fib. Again, here base condition is satisfied, so it returns 1. Fib of 3 from fib of 4 returns 1 plus 1, which is 2. Now 2 from fib of 4 is passed into function fib. Here base condition is satisfied, so it returns 1. Finally, function fib of 4 returns 2 plus 1, which is 3. So, the fourth value in the Fibonacci series is 3. This is how this function works. In recursion, first the functions present in the right side of the recursive tree is called, only then the functions in the left side of the recursive tree is called. Hence it follows the path of depth first search tree. Recursion internally works inside stack memory. Let's see elaborately about stack memory allocation. Stack will track all the function calls. The allocation happens on contiguous blocks of memory. We call it a stack memory allocation because the allocation happens in the function call stack. The size of memory to be allocated is known to the compiler, and whenever a function is called, its variables get memory allocated on the stack. And whenever the function call is over, the memory for the variables is deallocated. This all happens using some predefined routines in the compiler. A programmer does not have to worry about memory allocation and deallocation of stack variables. This kind of memory allocation is also known as temporary memory allocation because as soon as the method finishes its execution, all the data belonging to that method flushes out from the stack automatically. This means any value stored in the stack memory scheme is accessible as long as the method hasn't completed its execution and is currently in a running state. Let's now dive into internal working of the recursion function. Our program will start from main function, and it will be pushed into stack. Inside main function, we will give input of n and call the fib function. As our previous assumption, n will be 4. So, 4 is passed into fib function. Now, fib function of 4 will call itself with value 3 and 2. So fib of 4 is pushed into stack. Now, fib function of 3 will itself with value 2 and 1. So, fib of 2 and fib of 3 is pushed into stack. Here, fib of 2 will call itself and fib of 1 is pushed into stack. Now, fib of 2 will reaches the base condition and returns 1. Then, function fib of 1 is popped out of stack and it will call the function fib with n value 1, this reaches the base condition and returns 1. After that, fib of 3 will be popped out of the stack and returns 2 to the previous call. Now fib of 2 will be popped out from the stack and call the function fib with n value 2, as per the base condition, if the n value is 2, the function will return 1. Now, fib of 4 is popped out of the stack, and returns 3 to its previous call, which is the main function. Hence, main function will receive value 3 and prints it. Here's the difference between recursion and iteration. Recursion terminates when the base case becomes true, whereas iteration terminates when the condition becomes false. Recursion is used with functions. Iteration is used with loops. Every recursive call needs extra space in the stack memory. Every iteration does not require any extra space. Smaller the recursion code size, larger the iteration code size. Types of recursions. Recursions are mainly of two types depending on whether a function calls itself from within itself or more than one function call one another mutually. The first one is called direct recursion and another one is called indirect recursion. Thus, the two types of recursions are direct recursion and indirect recursion. 1. Direct recursion. These can be further categorized into 4 types. Tail recursion, head recursion, tree recursion, nested recursion. Tail recursion. If a recursive function calling itself and that recursive call is the last statement in the function, then it's known as tail recursion. After that call, the recursive function performs nothing. The function has to process or perform any operation at the time of calling, and it does nothing at returning time. Head recursion. If a recursive function calling itself and that recursive call is the first statement in the function, then it's known as head recursion. There's no statement, no operation before the call. The function doesn't have to process or perform any operation at the time of calling, and all operations are done at returning time. Tree recursion. To understand tree recursion, let's first understand linear recursion. If a recursive function calling itself for one time, then it's known as linear recursion. Otherwise, if a recursive function calling itself for more than one time, then it's known as tree recursion. Nested recursion. In this recursion, a recursive function will pass the parameter as a recursive call. That means recursion inside recursion. 2. Indirect recursion. In this recursion, there may be more than one functions, and they are calling one another in a circular manner.